Hi to everyone. I am Dr VNSR Venkateswara Rao, working as an Associate Professor in the Department of Chemistry in the Institute of Aeronautical Engineering, Hyderabad. So, first of all, today I would like to give the topic on the numerical problems on EMF of a voltaic cell. So, before starting the topic, what are the contents in today's session? So, first of all, we see introduction to the EMF of a voltaic cell. Next, we follow the model problems. So first of all, we see what is the electromotive force. That means the electromotive force is the maximum potential difference between the two electrodes of a galvanic or voltaic cell. That means if the cell potential is negative, the reaction is reversed. In this case, the electrode of a galvanic cell should be written in a reversed order. So first of all, what is the meaning of galvanic or voltaic cell? That means the chemical energy converts into a electrical energy. That means, for example, by taking a redox reaction, in redox reaction, what happens? It involves both oxidation and reduction reactions. It involves both oxidation and reduction reactions. That means the reaction simultaneously takes place, both oxidation and reduction reactions. That is nothing but a redox reaction. So, for example, if you can take as galvanic cell, there are two electrodes are present. The one is anode and another one is the cathode. Anode is nothing but zinc electrode, and cathode is nothing but copper electrode. So that means always the zinc is present in zinc sulfate solution and copper is present in copper sulfate solution. So the reaction of the redox type takes place in between the zinc and copper. We see the reactions, nothing but at anode, what happens? Zinc undergoes oxidation, that means zinc plus 2 electrons. And at cathode, what happens? The copper plus 2 ions absorb the 2 electrons to get copper solid. Okay, now we see overall reaction, nothing but zinc plus copper plus 2 gives rise to zinc plus copper plus 2 gives rise to zinc plus 2 plus copper solid. So that means from the zinc to zinc plus 2, what happens? Oxidation takes place. And from copper plus 2 copper, what happens? Reduction takes place. That means the reaction simultaneously takes place, both oxidation and reduction reactions. Finally, it releases the electrical energy. So by the transfer of electrons from zinc to copper, that means flow of the electrons. That means it starts with the chemical energy and ends with the electrical energy. We understand that chemical energy converts into a electrical energy. So that is nothing but a galvanic cell or voltaic cell. Okay. So the definitions of electrical units that were proposed at the 1881 International Conference of the Electricians were designed so that the electromotive force of a Daniell cell or voltaic cell would be about 1.0 volts. Okay, so with contemporary definitions, the standard potential of the Daniell cell or voltaic cell at 25 degrees centigrade. At 25 degrees centigrade, nothing but room temperature, that should be equal to 1.10 volts. Okay, now the formula for determination of a EMF of a voltaic cell or Daniell cell, that should be equal to E cell is equal to the potential at cathode and the potential at anode. So that means already discussed about in a galvanic cell what happens. The anode is nothing but a zinc electrode and a cathode is nothing but a copper electrode. Always at zinc, what happens? Oxidation takes place, and always at cathode, what happens? Reduction takes place. That means anode present at left side and cathode present at right side. Now let us see the model problem. Calculate the EMF of a voltaic cell, nothing but electromotive force. So the maximum potential difference between the two electrodes when the charge transfer takes place. That means iron present in iron plus 2 aqueous solution when both are separated by salt bridge, and copper plus 2 present in aqueous solution in copper. Give the electrode potentials of the copper and iron are 0.34 volts and minus 0.44 volts. So in this case, we observed that 0.34 belongs to the cathodic potential, that means copper reduction potential that can act as a cathode. Okay, and minus 0.44 volts, nothing but iron oxidation potential occurs at anode. Okay, now according to formula, E cell is equal to the potential at cathode minus the potential at anode. So that means what is the cathodic potential? That should be equal to 0.34 volts minus, and what is the anodic potential? Minus of minus 0.44 volts. So finally we got 0.34 minus of minus. Finally we got 0.34 and minus of minus plus 0.44 volts. We get 0.78 volts. That means the cell potential. So that means they ask the calculate EMF of a voltaic cell. That should be equal to 0.78 volts. Okay, so this is the solution for the given model problem 1. Now let us see the model problem 2. Calculate EMF of a voltaic cell. Zinc present in zinc plus 2 aqueous solution, and when both are separated by a salt bridge, and copper plus 2 aqueous solution copper metal. So give the electrode potentials of the copper and zinc are 0.34 volts and minus 0.76 volts respectively. So that means 0.34 volts nothing but copper reduction potential occurs at cathode, and minus 0.76 volts nothing but zinc oxidation potential occurs at okay. Now the formula is E cell potential is equal to the potential at cathode and the potential at so that means the potential at cathode should be equal to 0.34 volts minus of the potential at anode nothing but minus 0.76 volts. That means 0.34 minus of minus plus 0.76, we got 1.1 volts. So they ask the EMF of a voltaic cell, that should be equal to 1.1 volts. Okay, so this is the solution for model problem 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.